Welcome to Demystifying Math. In this lesson, we're going to be graphing a hyperbola, and we're going to use the completing the square method to find the center of the hyperbola. If you're given an equation for a conic in the alternative form, where you have ax squared plus cy squared plus dx plus ey plus f equal to 0, what you're going to have to do is use the completing the square method to find the center of the conic. We're going to use this example. Negative 9x squared plus 25y squared minus 36x minus 200y plus 139 equal to 0. In this case, our coefficient of x squared is negative 9, and the coefficient of y squared is 25. Those are our a and c values. If your a value and your c value are opposite signs, in other words, one positive, one negative, you're going to have a hyperbola. It really doesn't matter what the value of a and b are. As long as they have opposite signs, it will be a hyperbola. Remember that the only way that you can get a circle is if they have exactly the same values. So they would either both have to be negative or both positive. So for instance, if a was negative 9 and c was 9, they're still opposite signs, so it's still going to be a hyperbola. If they were both negative 9, then it would be a circle, or if they were both positive 9, it would be a circle. Okay, so what you have to remember is that if it's a hyperbola, a and c are going to be opposite signs, one positive, one negative. Okay, so what we're going to do is complete the square in order to find the center of the hyperbola. So we're going to group together our x terms and group together our y terms. Then what we're going to do is factor out the coefficients of x squared and y squared. So for x, our coefficient is negative 9. We're going to factor that out. So in other words, when you're factoring, you're always dividing. So dividing negative 9 into negative 9x squared gives you x squared. And dividing it into negative 36x, you get positive 4. Now for the y squared term, our coefficient is 25, so we're going to factor that out, or divide it out. So we got y squared, and 25 goes into negative 200 8 times, negative 8 times, so we're writing negative 8y. Now what we want to do is complete this square. So we need to find a number that's going to make what's in the parentheses a perfect square. And we can do that by taking the coefficient of x, taking half of it, and squaring it. Do the same thing with the coefficient of y, which is negative 8, take half of it, and square it. So for the x term we got 4, and for the y term we got 16. So we're adding that inside the parentheses. Now when you add it inside the parentheses, you always have to remember that what's outside the parentheses is going to be distributed to that number. So in this case, I got negative 36 is the change in the equation by putting that 4 inside the parentheses. So I have to also take the negative 36 away from the other side of the equation to keep the balance. Now for the y terms, the 25 is going to be multiplied by 16, which is 400. And that's going to have to be added to the other side of the equation. Now we're going to factor our perfect squares and combine our constants. So x squared plus 4x plus 4 factors into x plus 2 all squared. And y squared minus 8y plus 16 factors into y minus 4 all squared. Remember, if your middle term is negative, you need to make sure that you have a negative when you factor it. Then our constants combined together give us 225. Now we're going to divide both sides by 225. And we're doing that so that we get the equation set equal to 1. And we're also going to simplify and put our positive term first. So our positive term in this case is the y term. So where we had 25 over 225, that simplifies to 1/9. And where we have 9 over 225, it simplifies to 1 over 25. And I brought the negative here for the x. Now what we have is our equation in conic form, and it's very easy for us to identify the center of the conic, or the hyperbola in this case. Remember that when you're looking at a hyperbola, one of the terms is going to be negative and the other one is going to be positive. And that's what we meant by having that a and c being opposite signs, one positive, one negative. That's what indicates that this is a hyperbola. Okay, so now we can identify our center, which is at HK. So our center is going to be at negative 2, 4. A is going to be the distance from the center to the vertex. Since A is under Y in this case, the vertices are going to line up vertically. So whichever term is positive indicates which direction it opens. So remember, Y is always a vertical movement, X is always a horizontal movement. So if the Y is positive, it's going to line up vertically for your vertices. If X was a positive term instead, the vertices would line up horizontally. So the vertices are going to be 3 units away from the center. So we're going to take their center point and move up 3 and down 3. So we end up at negative 2, 1 and negative 2, 7. We can also find the slopes of the asymptotes by using A and B. The slopes are going to be plus or minus A over B. Now I know whether it's A in the numerator or B in the numerator based on what letter it's under. So remember again that Y is a vertical movement. So when you're talking about slope, it's going to be rise over run. So our A value is going to be our rise, which is 3, and our B value is going to be our run, which is 5. Now it's pretty easy to find the slopes of the asymptotes because the two asymptotes will always go through the center of your hyperbola. So we have a point on our asymptotes and we have our slope. So we're going to use the point slope formula to find the equations for our asymptotes. So the point slope formula is y minus y1 equals the slope times x minus x1. I'm going to start with the positive slope line first. So I plugged in 3/5. And I also plugged in my center, which I know is a point on my line. So I plugged in the negative 2 and the 4. Then I distributed the 3/5 and got 3/5 x plus 6/5. And then I'm going to bring the 4 over to the other side. Adding it to 6/5 gives me 26/5. So this is an equation for one of the asymptotes. Now to find the second asymptote, we're going to do exactly the same thing, except we're going to change our slope to a negative 3/5. So I have the negative 3/5, and I'm distributing it to the 2, so I got negative 6/5. And I'm going to add 4 to negative 6/5, and that's going to give me 14/5. So this is the second equation for an asymptote. Now we can sketch the graph. We know where our center is, and we know where our vertices are, and we know what our asymptotes are. So we're going to go ahead and graph it. Now remember that we said that this is going to, our vertices are lining up vertically, so our graph is going to open up and down. Our center is marked here, which is halfway in between the two vertices, and the two asymptotes are graphed. Now the only other thing that we need to know about this graph is where the focal points are. So you can find the focus. The distance from the center to the focus is C. And C can be found by using the equation a squared plus b squared equals c squared. So plugging into that, we have A is 9 and B is 25. And add them together, we get 34, and that's going to give us c squared. Then square rooting both sides, we have c is equal to plus or minus the square root of 34. So you can find the foci because they're in line with the vertices and the center. So we want to move from the center up square roots of 34 and down square roots of 34. So we're going to add it and subtract it to 4. So we get approximately negative 2 and 9.83 and negative 2 and negative 1.83 for our focal points. Okay, thank you for tuning in to Demystifying Math.